Matt Pocock's talk title says it directly: it ain't broke. Why software fundamentals matter more than ever. That is the right sentence for this moment. AI makes it feel like the craft has moved past the old rules, but the opposite keeps being true. The more powerful coding agents get, the more the old fundamentals look like load-bearing infrastructure. AI did not make architecture obsolete, it made architecture the control surface. AI did not make testing obsolete, it made tests the contract the machine cannot argue with. AI did not make domain language obsolete, it made language the boundary between useful generation and semantic drift. The most tempting AI story is simple. Describe what you want, let the model build it, tweak the prompt until it works. That is the dream behind specs to code and vibe coding. And there's a real version of it. AI coding tools can compress days of boilerplate into minutes. Many builders have experienced this. You ask for a feature, the tool scaffolds it, and the project jumps forward faster than by hand. But there's a trap inside that experience. The first generation feels magical. The second starts patching around the first, the third patches around the patch. Eventually the system stops feeling designed and starts feeling sedimentary. Each prompt adds another layer, each layer solves the local symptom while making the global structure harder to understand. That is the doom loop of probabilistic delivery code. Generation is cheap, bad code is still expensive, and AI can generate bad code at a scale that makes old technical debt look slow. Software engineering used to be deterministic authorship. A human decided what the program should do, translated intent into code, and debugged the result. AI-assisted engineering is different. The human is increasingly designing a system around a probabilistic worker. The worker can produce useful implementation, but it can also hallucinate APIs, flatten domain distinctions, overfit tests, or rewrite unrelated parts of the system. That means the builder's job moves upward. The valuable skill is not just knowing how to write the loop, it is knowing what boundaries must exist before the loop is written. Domain-driven design has always cared about language. A term should mean the same thing in conversation: requirements, code, and data. In the AI era, that discipline becomes even more important. LLMs are very good at producing plausible language. That is part of the problem. If the domain language is loose, the model will smooth over ambiguity with words that sound reasonable but do not map to the real system. A ubiquitous language becomes an AI constraint. The glossary is no longer just documentation for humans, it is a semantic anchor for the agent. Before asking for code, make the language precise. Test-driven development used to feel slow. Write the failing test first, make it pass. Refactor, repeat. With AI, the economics invert. The machine can generate test boilerplate quickly. The human focuses on whether the test expresses the right behavior. A failing test turns the problem into a small executable contract. The instruction becomes, make this specific behavior true without breaking the rest of the suite. That is a much safer interface for a probabilistic system. Test first prevents one of the most dangerous AI mistakes: writing tests after generated implementation. When the model writes code first and tests second, it can easily produce tests that validate its own broken assumptions. John Eysterhout's idea of deep modules feels purpose-built for AI-assisted engineering. A shallow module has a complicated interface and very little hidden depth. It forces scholars to understand too much. A deep module hides substantial complexity behind a simple interface that was already good design for humans. It is even better for LLMs because models operate inside context windows. If a feature is scattered across a dozen shallow abstractions, the agent has to reconstruct the system by jumping between fragments. Deep modules give the agent a better target. The public interface stays small and stable. The internal implementation can be large and AI modifiable. If AI increases generation velocity, the pipeline has to become more than a deployment conveyor belt. It becomes the enforcement layer. Traditional CI asks, does it build? Do the tests pass? AI era CI has to ask more. Did this change add implementation without tests? Did it violate a bounded context? Did it introduce a shallow abstraction? Did it change behavior outside the intended module? The agent needs structure, prompts as code version review instructions, static gates, traceable artifacts. Agentic DevOps is not let the robot merge everything. It is the construction of a system where automated workers can move quickly because the environment makes unsafe movement visible. For builders, the practical lesson is not to reject AI coding. The lesson is to stop treating AI as a replacement for software fundamentals and start treating software fundamentals as the way we use AI safely. Interrogate before implementation. Write the language down, test first. Prefer deep modules, make CI opinionated, use workers with roles, log the failures. This is how builders turn AI from a clever autocomplete into a delivery system. The relearning pipeline is a small version of the same pattern. On the surface, it is a content pipeline, but structurally, it is an AI-assisted engineering system. The draft coordinator researches in drafts, W1 orchestrates, W2 owns audio, W3 owns video. Workers use short callback vocabulary, artifacts live at known paths, run learnings capture errors, so the next run is better. That is software fundamentals applied to content automation. The most important AI-era engineering skill may be the ability to design constraints that preserve intent. That sounds less exciting than build an app from a sentence, but it is what separates demos from durable systems. Anyone can generate code now. Not everyone can create the architecture where generated code remains useful after the fifth change, the third worker handoff, the first production bug, and the next domain requirement. AI raises the ceiling on what one builder can attempt. But it also raises the penalty for weak foundations. Software fundamentals are not the old world resisting the AI era. They are the interface that makes the AI era buildable.